Okay, welcome. I am back with Chapter 4 homework for this week, and I'm going to record it on our worksheet, basically. I think that works better because of all these story problems that we have, so hang in there with me, and I'll see if I can walk you through this. Alright, starting with number 1 here, it says compute the total cost per year of the following pair of expenses, then complete the sentence. On an annual basis, the first set of expenses is what percent of the second set of expenses. Alright, so it's going to go on here to say that, get that out of the way, that Vern buys 4 lottery tickets each week at a cost of $5 each and spends $850 per year on his textbooks. Alright, so let's get the 4 lottery tickets each week at a cost of $5 each. Okay, so that's going to be 5 times $5 each a week. So that's going to be 4 lottery tickets at $5, and for 52 weeks then, 52. Okay, so that looks like that's going to give me 850. Nope, it's going to give me 1,040. This equals 1,040. And then Vern also spends $850 per year on textbooks. So, of course, that's 850. So there's the first set of expenses is the 1,040, and the second set is 850. So on an annual basis, the money spent on lottery tickets is what percent of the money spent to buy textbooks. So you could say 1,040 is what percent, I'll say P for percent, of 850. Okay, if I rewrote this, it would be 1040 equals 850 P per percent. You can make that P any letter you want. I like to designate it as whatever it is I'm talking about. So in this case here, I'm going to divide both sides by 850. And X equals, or P equals, like this, our little algebra here from pre-algebra. So I've got P equals, and this ratio here becomes 1.22. Okay, and what do I do with that? I move it over 2 places or multiply it by 100 to give me 122% equals P. Okay, so that's our answer for el numero uno. Alright, first one. We got 28 problems altogether, so we'll be here for a while. Okay. Okay, this next problem is find the monthly interest payment in the situation described below. Assume that the monthly interest rate is 1/12 of the annual interest rate. Okay, what we're going to need here in this type of problem is a formula which is called the simple interest formula. And the simple interest formula, simple interest, and we use this when they're not mentioning the word compound. 2 different types of interest problems, where it's compounding interest, which we're going to be doing a lot of in this chapter coming up soon, and then this simple interest. So simple interest is where the interest equals your principal amount times the rate that it's paying in percentage times time. And time always comes in years and the simple interest rate. Okay? So if it were 1 year, T would be 1. If it were 5 years, T would be 5, etc., etc. In this case here, in this problem, it says you maintain an average balance of $600 on your credit card, which carries an 18% annual interest rate. And if I took that annual interest rate, that means annual means 1. Okay, so in this case here, I've got the interest, that's what we're solving for, equals the principal amount, which is the $600, multiplied to the rate, which is 18%, and I write that in decimal form of 0.18, and multiply that to the time. Well, if time is in years, this is 1/12 of a year. Where'd it go? Right over here. 1/12 of the annual interest rate. So that means like 1 month of that. So I could use 1/12. And use your calculator to plug that in, hoping you have the feature of the parentheses and etc. But needless to say, the interest here is going to equal, when you multiply all this together, I get the interest that you're going to get is 9. And that's what you would pay on your credit card if it was 18% for the course of the year, $600 only. Okay, so that's what I should say the monthly interest payment is 9. If it were yearly, it would be 9 times 12. Okay, so that's the monthly interest that you're paying, which is 9. Okay, that was number 2. Okay, number 3. For the example below, prorate the given expenses to find the monthly cost. Okay, let's see what it says here. Sarah pays $5,400 for tuition and fees for each of the 2 semesters, plus an additional $260 for textbooks each semester. Prorated monthly costs for the items there is, well, let's do it this way. I'm going to have 5,400 times 2, 10,800, and then we have 260 times 2. It gives you 520. 520. Got the dollar mark. Okay. So what do we want to do? Add these 2 items together to give us 11,320. And since we want the monthly cost, I'm going to divide this figure by 12. And when I figure that divided by 12, I'm going to end up with 943. Okay, remember to round it. This is saying round to the nearest dollar as needed. Okay, pay attention to that, what they're asking you to do with that, as far as rounding goes. Okay, done with number 3. Okay, number 4, that's what this is here. Number 4, if I can get that in there a minute. Oh. Number 4. So the expenses and income of an individual are given in the table form to the right. Find the net monthly cash flow. It could be positive or negative. Assume salaries and wages are after taxes. When you need to convert between weeks and months, assume that 1 month equals 4 weeks. Okay, let's make a note of that. And we want the net monthly cash flow. Alright, let's see if I can do it this way here. So I've got income here, let's see, I get, for income, we get $600 a month, so it's already in monthly cash flow, so this is 600 a month. Convert everything to months if we have to. The college fund from grandparents, $300 a month. That's nice, $300 a month from grandma. And the scholarship, $6,000 a year. So that's going to equal, divide that by 12, and what's that going to give you? $500 a month for the scholarship. Okay, so our net income here is going to be this amount. 9 and 5 is 14. Okay. And let's do the same thing with the expenses here now as well. So rent is going to be $400 a month. Groceries, $60 a week. So remember over here it says to convert weeks to months, so 4 weeks. 4 times 60 then would be 240. Tuition and fees, $2,400 twice a year. So you could do 48, double that twice a year would be 4,800 divided by 12, and that'll give you 400. 48. 400 times 12, so it'll give you 400. And finally, incidentals, $80 a week. Again, times 4 would be 320. There we go. Add these up for the expenses, and you get $1,360. Okay. And what's your net monthly? Your net monthly cash flow is going to be $1,400. How much you take in, and less how much you spend, so you got a monthly cash flow of $40. Yikes. Okay. That's it. That's it for number 4. Okay, you have a choice between going to an in-state college where you would pay $6,000 per year for tuition, and an out-of-state college where the tuition is $9,500 per year. Cost of living is much higher at the in-state college, where you can expect to pay $750 per month in rent, compared to $400 per month at the other college. Assuming all other factors are equal, which is the less expensive choice on an annual 12-month basis? Okay, so it looks like, let's draw a little chart here maybe to help us figure this out. So we've got the in-state, and out. Okay, so the in-state we had $6,000. Then we had rent of $750 times 12. Okay, which equals 9,000. And of course 6,000 equals 6,000. Altogether that's 15,000. We're going to take that 15,000 divided by 12, and that's going to give us $1,250 monthly. The out-of-state college is $9,500, and then rent there was $400 a month. Okay, so that's going to give you your $4,800 here, and $9,500 is $9,500. Just lining them up, I guess, is what I like to do. I add these up and I get 14,300. this by 12. Okay, and I guess I'll go this way with it. This equals $1,191.67. Okay, and what's the least expensive? The out of state. Out. Which doesn't seem right, but alright. Okay, here we're going to need a little algebra. It says, suppose that you currently own a clothes dryer that costs $25 a month to operate. Okay, $25 a month to operate. A new efficient dryer costs $540 and has an estimated operating cost of $15 per month. So a little cheaper to run per month after you spend $540. How long will it take for the new dryer to pay for itself? Alright, so what I want to do is get two equations for this. So if I have a clothes dryer that costs $25 a month to operate, I could write that up as 25 times however many months that we want to figure out for. So that is the variable. I'll write it up as m, 25 times m. And I want to equal it to what the new dryer is. So in other words, I want to have it read, well, it costs $540 plus the cost of operating it, and that the newer one is $15 a month. So I want to know, when will it pay for itself? When will these two equations be equal to each other? I'll solve for m to figure that out. Okay, so here I've got 25m and 15m on either side of the equal sign, so I want to bring the one on the right over to the left by adding the opposite of 15, which is minus 15. The same thing as saying subtract 15m to both sides. And I end up with 10m equals this 540. I want to get the m by itself, so at this point I'm going to divide both sides by 10, and m equals 54. And the m stands for months. That's how many months it'll take for it to pay for itself, this dryer. 54 months, it's almost like 5 years, right? So 4.5 years. Okay, so that's what we were looking for. Alright, and that was number 6. Let me jot it down here. Number 6. Okay, this problem, we're just going to encourage you to use your calculator. By the time I explain the math behind it, we can figure this out. So on your calculator, you're going to type in on the this is the TI. I hope you have this, of course. TI 83 or the 84. But you're going to type in, you're going to punch in 4, and then you're going to look for this little caret, looks like something like this on the calculator, and it looks like it's right below the clear button. And once you plug in that, let me take a look at mine. It's going to look like 4, then you're going to raise it to the they're slightly different now in these calculators between the 83 and 84, but it's going to have a little box here, with or without the caret. And in here you're going to put the -2. Put the -2 in the little box, and the negative sign you want to use is down on the very bottom of the calculator on the right side next to the period or the decimal. There is a negative number in parentheses. That's the one you want to use to emphasize a negative number. So when you plug that in, then you're going to end up with a decimal number, okay, and that decimal number would be like 0.0625. 0.0625. Okay, but now what you want to do is change it to a fraction. Change it to a fraction. Because that's what they want as part of our answer. And the way you change it to a fraction is you go to, I'll write it down here, you're going to hit the math key, left side, below alpha, the green button. Okay, you're going to hit math, and then you're going to hit number 1 where it says for fraction. So you're going to hit number 1 for fraction. Or just hit number 1 or enter, and then you're going to hit it again. Notice what it does, it takes the answer, then you got an arrow going to fraction, and then it's going to change it to the decimal that you want, so something like that. Okay, and then you come up with 1/16. So you can mess around with that, practice a little bit, you know, do anything like 3 to the -2 maybe, something like that, which should give you 1/9. So if you want to practice that, go right ahead, and that's how you do it. Here's problem number 8. I'm just writing it out here. It's fairly simple. I want to solve for P. A little bit of algebra here. That's what our next couple 3 problems are. So isolate P by adding 4 to both sides. So P comes down, -4 plus 4 is 0, I don't have to write anything, equals 28 plus 4, which is 32. Okay, and that's all we need for number 8. Okay, how about number 9? A little bit, another step to do on here, but I want to isolate the x here, so let's get rid of this -3 by adding 3 both sides. If I do one side, I got to do to the other. Bring down the 8x, and that's going to equal 72. Get the x by itself by dividing both sides by 8. Therefore, x equals 72 divided by 8 is 9. And there's our solution for 9. Number 10. Here I've got a y. The y, as I observe this, analyze it, I got a y on the left and a y on the right. So I want to get them all to the left. I always pick on the left side. So that means if I got a variable on the right side, I want to get rid of it by subtracting adding or subtracting the opposite. So in this case, I'm going to subtract 4y. If I subtract 4y on this right side, I have to do it on the left side. And I'm doing it with the like terms here. So 4y. So draw my line here. So here I've got 5y minus 4y is 1y plus the 8. That equals, my y's cancel out on the right side, that was my intention. And then I'm going to bring down the -5. Don't forget the negative here. That's determining a -5. Okay, that's important. And then from here, I'm going to get the y by itself by getting rid of the 8 that's with it. So I'm going to subtract 8 both sides. So I've got y equals -13. Okay, we're done with number 10. Okay, last one for the little algebra problems here. Same situation, I got an x on the left side of the equal sign and an x on the right side of the equal sign. So I'm going to get rid of this x first. So by subtracting 6x. So I've got 2x plus 2 equals 24. Now I've got got the 2 with this 2x, so I want to get rid of the 2 by subtracting 2 on both sides. Bring down my 2x. This is 0. That equals 22. And now in this case, to get 2 by itself, I've got to divide both sides by 2. Because this is 2 times x, so in order to undo that, I've got to use division. So x equals 11. Okay, number 11. 11 for 11. Okay, number 12 here is calculate the amount of money you'll have at the end of the indicated time period. Alright, reading this carefully, it says you will invest $3,000 in an account that pays simple interest. Remember what I mentioned about simple interest before, of 6% for 20 years. Okay, so I've got my principal here, my rate is here, and my time is here. And that's all we have to do. It says the amount of money you'll have at the end of 20 years. So I have to have the total amount of money, not just the interest. So the simple interest is that the interest equals the principal, which in this case is 3,000, times the rate of 0.06 times the time of 20. 20 full years now we're talking. Okay. And once I get that, what's the interest going to be? 3,600. So this gives you that the interest equals 3,600. But then I want to add back the 3,000. Remember, 20 years, so you're going to get a substantial amount. So it looks like it's going to be 6,600 altogether. Okay, so we figured out what the interest was, which is the 3,600, and then we're adding back the principal amount of 3,000 to determine how much we have at the end of 20 years. Not just what was the interest, how much interest did we get? How much do we have at the end of the 20 years? So that's number 12. Okay, another. Calculate the amount of money you'll have at the end of the indicated time period, assuming that you earn simple interest. Again, there's simple interest formula. So I've got the interest equals, so you deposit $3,000 in the account, that's the principal, with an annual interest rate of 3.4%. So that's going to be times, let's see, I'm going to move this over 2 to give me 0.034, changing that percent to a decimal, or again, multiply it, or divide it by 100 for 15 years, and that's this is my rate, this is my time, 15. So the interest on this is, what do you get, 1530 when you multiply this together, then add on the original 3,000, and how much, the amount of money you'll have at the end of 15 years is, add these two up and you get what, 4530. Okay, alright, carefully answering those questions. Okay, critical part of the lesson in chapter 4 in all these problems. We're coming to the magic words here of compound interest. Right here. Use the compound interest formula to compute the balance in the following account. after stated period of time, assuming interest is compounded annually. So let's take a few minutes here and go over some terms that you're going to need to know. Okay. Number one, compound interest formula. We're going to replace the formula with the use of the calculator. Alright, we're going to use this TI 8384. It's much easier to do, less chance of making errors, and we got this technology and we're using it, of course. We're not going to do this manually that way. Okay, next, and then we got to get some terms of compounding, the ways that you can compound. So you can compound. Here's the terms I'm going to use for now. Okay, so I'm going to start with. I'll come over here. Then I guess let me come down here. How about that? Separate little lesson here. So number of compounds. Chicken scratch writing. My number of compounds per year. Okay. So let's start with something maybe that is monthly. Monthly. And how many if you're compounding something monthly, that represents the number 12. 12 months in a year. Used for when you have payment problems. The compound number is going to be 12 times a year, depending on how many years. Okay. Next term is going to be something that is compounded quarterly. Quarterly. And that number represents the number 4. 4 times a year, some money is compounded quarterly. Semi-annually. Semi-annually is, well, if annually is 1, semi-annually is going to be 2. And let's do the annually. Probably doesn't even need an explanation now. Annually means 1 time a year. Something is compounded annually. Daily. What's daily? How many days in a year? 365. Next year there will be 366 because of leap year. Next year is a leap year. And then if I had one more here, I'll just say, I haven't seen this, but if it were compounded weekly, then that would mean what number? How many weeks in a year? 52. Okay, so that gives you a sense of what numbers are associated with these terms, and it says so in the problem, so we're going to have to think of those numbers as we're doing problems, depending on how the problem is stating it. Okay, got that. And, well, let's scroll down here a little bit more if I can. Now I want to teach you about the calculator and where to go and how to solve these. So what you're going to do is you're going to turn your calculator on and hopefully have the TI-84. It's slightly different in the TI-83. This is the TI-84. And what it has here is what's called the apps key. And the apps key is next to the math key. And it's in, what color is that? Purple or? So that is, it's labeled apps. Push on the apps key and then you'll see number 1 is the finance key. I'll write the word out here, finance. And then hit number 1 or enter because you're going into the finance key, and then you're going to find the TVM solver. TVM, time value of money. solver. Okay, that's number 1 as well. Hit that, and then here's our featured screen. Okay, and this is where I'm gonna write it out here to be the N, the I. I'll put the percent there, like your keyboard has. What else do I have here? PV. PV payment. FV, future value, and then this PYCY. PY is the per year, compound, or P stands for periods per year, or compounds a year. These numbers will always be the same for PY and CY, depending on whatever the problem is stating. If it's compounded quarterly, then this is 4 and this is 4, and it goes in virtually automatic. Okay, so here's our key, if you will. This is kind of like what it looks like, and we're going to fill in all these values, this table with the values that we get from the problem. Okay, N stands for the number of compounds in the problem. So for example, if I had something that was compounded for 2 years, quarterly, that would be 2 times 4. Okay, 2 years compounded quarterly. If it were compounded daily for 5 years, then it would be 5 times 365. And you can calculate it right in that screen on that line. You have to do it separately, then plug it in. Just type this right in there, and then your answer will pop right up. Okay, so that's the number of compounds. Interest is as the number is given to you. You don't have to change it to a decimal. So if it's 3%, then you write 3%, just 3 rather. Okay. Present value. PV is present value. Again, we're going to go through some examples. If I'm investing amount of money, that's what I have presently. That's the amount that would go here. A dollar amount would go here. Payment, for when we're determining what the payment is, or if I'm making a payment. And that's self-explanatory. FV, this is future value. If you're investing money with your present value of dollars, how much is it going to be in the future? Conversely, you're going to have a number of dollars that you need in the future. How much should I put in the bank now, presently, so I'll have that money in the future? PYCY, again, depending on what the number of compounds is. So if I looked at this top number, the number of compounds, I said 2 years and compounded quarterly. Well, the 4 would go down here in the PY and the CY. The number of compounds per year. This is including the number of years with the number of compounds per year. Okay, we'll go through several examples and see how it turns out. Let's go back up to the top. Here it is here. Okay, so I've got number 14 here. I'm going to get a little thinner pen here. I think I'm going to need it. Okay, let's do something like change colors boldly. So I've got, I'm going to write out my table here. Let me do it over here. N, I, PV, okay, now I'm going to have you scroll with your scrolling buttons there up and down. When you go from one problem to another, you can type right over the old problem to get your values in there. It does not matter. Oops, got a light. Okay, so here we go. I've got here's my values here. 11,000 invested at an APR of 3.4% for 21 years. Okay, and this is assuming interest is compounded annually. So that means 1. So for the N here, this is going to be 21 years times 1 time a year. Okay? The interest is just simply 3.4. PV, the present value of this investment, is $11,000. The payment doesn't apply. We're not doing payments, so just put a 0 in there. You have to have something in there, a numerical value like 0 fills that. If you don't, then it won't operate. The program won't operate for you. The future value of this investment, that's what we're looking for, so we can leave that with a 0 as well. The PY and the CY, well, that's going to be the number of compounds per year, so in this case it's annually, which means 1. So if you put 1 in here for the PY and toggle down, it'll pop in there automatically, or you can try it and you'll just see that it happens. Okay, so this is what I've got. And now when you've got all your values filled in for these categories, you're going to scroll up to future value here and have that cursor blinking on the 0. And then from here you're going to hit your alpha key, the green key, hit alpha, and enter. Okay. And then your total's going to come up. And did I do this one? I didn't do this one. I'll be right back. Okay, I came up with the number 22198. Decimal 52. So you got some rounding there to do. Okay, so after 21 years, long time to have your money invested without using it, 11,000 grew to 22,000. Okay, here's our first example using this table here. Okay, we'll use that a lot. And this is on your calculator, and I'm rewriting it every time, so I feel I need to, since I can't do a video of it. I guess I could. Okay, here's another. Almost the same, different years, different amount of interest. Okay, so let's plug it in. So here I've got, assuming interest is compounded annually, here, use the compound interest formula to compute the balance in the following account after the stated period of time, assuming interest is compounding annually. So we know that annually means 1. So this is 11,000 invested, so let's write it in as we go. So the present value here is 11,000, and then the interest rate is 3.8%. The payment we're not messing with, we're not doing that. The future value is what we're solving for. PY, CY is going to be 1 again, right, because it's compounded annually. And then we got to go up to the top. The N is going to be 18 this time. 18 times the number of compounds per year, which is 1. So it's 18 times 1 is 18. Alright, no big deal there. Alright, so then when I go down to the future value here I'll get a little cute maybe here, and I'll use here's my green button that you're going to hit. You'll hit the green alpha key and then enter. Alpha, enter, and you're going to get a value here of $27,569.48. Okay, that's what you should have for number 15 then. Excuse me, correction. answer to that one, number 15, I was looking at the wrong answer here. It should be $21,525.09. I told you 27,569.48. Nope, it is 21,525.09. So I stand corrected. Everything else is fine. Just input alpha enter. Okay, that's 15 corrected. Okay, number 16. Use the appropriate compound interest formula to compute the balance in the account after the stated period of time. 15,000 invested for 8 years with an APR of 2% and quarterly compounding. Okay, so the N here is going to be 8 years times quarterly compounding, which is 4. Times 4. Okay, what number is this? 16. And the interest here is going to be 2% for the interest. The present value. Present value is the amount invested, so that's the 15,000. Payment, not doing payment, nothing to do with that. Future value, that's what we're solving for. Use my color coordinated green key here. Kind of tell you that if you need that. And the PY and CY, well, this is compounded quarterly now. So this isn't going to be 1, it's going to be 4. Just like so. There's all our categories filled in. We go back up to the future value, and then we hit our alpha enter key, and we should get our future value for number 16 is going to be 17,595